first one, right? If I plug in pi, is there a problem? Yes. So I need to do what? Split it all apart, right? So we're going to write it as like cos theta, sine theta, over cos theta, over sine theta. And we love it when that happens because those ones cancel, which leaves us with sine over sine, and those cancel. And so I'm literally just taking the limit as theta approaches pi of 1, which means it's 1. Because we're all experts. We know now that the limit of a constant is the constant. Right? Good. Next one. Is there a problem with pi over 2? No, and I mean, if there was, there's nothing I can do to simplify it anyway. So, I'm just going to plug it in. So that means I'm going to get sine of 2 pi over 2 over 2 pi over 2. But we got big brains, so we know that like the 2's are going to cancel. So I'm really just doing sine of pi over pi. And sine of pi is 0. So we get 0 over pi, which is 0. The pi's? Because you cannot cancel something inside of the trig function with something outside of the trig function. Right? That's like this is like me writing f of pi over pi. I can't cancel the pi's because the sine is a trig function. So it's an actual function. It's like function notation. Any questions, or we feel good about that? We all feel good? Yes. Awesome. We're going to talk about continuity now. Wow, can't speak. Continuity is super easy if we think about it, right? It just means like it keeps going. What would be like the stupid man's definition of it, do you think? You learned this before, I promise you. Had to do with your pencil. You don't have to pick up your pencil, right? You just draw it without picking anything up. That means it's continuous, right? So that's our layman's terms, right? What we're going to do now is we're going to talk about it a little bit more mathematically. So for this function over here, we've got, well, underneath we've got a bunch of stuff. But first, let's fill in this like 1, 2, 3 here for what these are, okay? So what are the 3 things that we need to have? Well, if we think about it, we're probably going to need that the actual function, which in this case is g, so g of a has to exist. Like it needs to be defined, right? If it doesn't exist, clearly it's not continuous, okay? The next thing is that the limit as x approaches a of g of x needs to exist, meaning that it has to exist from both sides, right, and be the same thing. So then the third part is that those 2 things need to be equal. So the limit as x approaches a of g of x has to equal g of a, which is going to like equal a number, like some value, right? If that's not true, then it's got some kind of hole, it's got some kind of asymptote, it's got some kind of jump, something's not working, right? Yes. You don't know. Is that what you just said? Yes. Oh, crap. All right. So let's go and put this into some practice. Bear with me. I have to scroll up and down. You guys can look at it all at the same time. So if it's easier, look at your page. So what we're going to do here is we're going to have what a is equal to, or x rather. X is our a. And then we're going to talk about it in a bunch of different ways. So at -6, is the function defined? At -6, the function is not defined. -6, guys. It's a big hole right there. So if there's a hole, it's not defined. Okay? What is the value of the limit from the left? And what is the value of the limit from the right? From the left, it's 5. From the right, it's 5. You guys see that as we like move up and down here, right? As we go from the left and right, it's 5. So that means that the limit is 5. And it's 5, which means if it's the same for both sides, it's not defined. No. No. So then, is it continuous? No. It failed the first criteria. It didn't exist. Guys, I don't know how you could possibly have questions about this. What's up? Okay, what?
The one before the last question.
Okay, the limit.
We said that it's a hole. So if it comes from both sides, it gets to the hole.
Yes. Guys, that's the same thing we've been doing for limits since the beginning of this unit. Basically, if one of these boxes is not true, it's going to be a no, exactly. That's what we're doing. So now let's look at negative 3. At negative 3, is it defined? Yes, it's 2. And from the left-hand side, it was also 2. Right? If we scroll up and look at it, from the left side here, it was 2. From the right side, it's negative 4. If the two sides are not the same, what does that mean?
No.
Doesn't exist here. Therefore, if the limit doesn't exist, it's not continuous. All right, our next one, we're going to check out 0. X equals 0. Let's do them all at once. You ready? The value, negative 1. From the left-hand side, negative 1. From the right-hand side, negative 1. So if the left and right side are the same, that means the limit exists. If all of these are the exact same thing,
It's continuous.
yeah. I don't know why I'm putting like a dash. The answer is yes. Yes, it is. All right, should we try the next one? Can we do them all at once again? Was that too hard? Or are we okay?
Yes.
All right, we're going to do it. 2. X equals 2. At x equals 2, is it defined?
No.
No. From the left-hand side, what is it reaching up to?
Positive.
And from the right-hand side, we're dropping down to? All right, so this one's like really not continuous, right? It doesn't have a value. It went to infinity from the left. It went to negative infinity from the right, so the limit didn't exist. This one is definitely not continuous, right? If we don't know that that one's not continuous, we're in the wrong class.
You love saying that.
I do. Are you in the wrong class, Matthias? Is that what you're saying? Okay. So, x equals 6. All at once. It is defined at 1. From the left side, it's 4. And from the right side, it's negative 2. All right. So we got 1, 4, negative 2. Those are not equal, right? Therefore, there is no limit. And so, therefore, it is not continuous. All right, we got one more. 8. We got hope for 8. Okay, at 8. It's defined at negative 4. From the left side, we get to negative 2. From the right side, we get to negative 2. So, we've got negative 4, negative 2, negative 2. Those ones are equal, therefore, it does exist. The limit exists. Is it continuous? No, because these two things are not equal, right? These two need to be equal in order for it to be continuous. So those are not equal. That was a really long way to say something easy. Would you agree?
Yes.
Yeah? So we understand it?
Yes.
Everyone except for twos?
I do.
Just very sassy about that. All right. Graph of the function below. Okay? It's got a whole bunch of x values where it's not continuous. It's very easy to see that just by looking at it. Use the 3-part definition of continuity to determine whether or not it is or is not continuous. So, first one here at negative 8. At negative 8, does it exist? Yes. Right? So the way we're going to show this, so we do a little mathematical proof here, is g of negative 8 equals 4. Perfect. It passes the first one. Then, we have to have the limit existing. Well, in our case here, the limit from the left and right are both approaching negative 5. Would you agree? Yeah. So that means that the limit as x approaches negative 8 of g of x is negative 5. Perfect. Where's the problem? Those two things are not equal. So g of negative 8 does not equal the limit as x approaches negative 8 of g of x. Guys, I understand that that's a lot to write. That's because this is a proof. This is your justification. Literally one of your standards in calculus, or especially AP calculus, is like, can you justify your answer? And when you write the AP test, that's one of the things they're going to check more. So if you take an FRQ with 9 marks, you're going to get like 2 for having an answer, and you're going to get 7 for like justification and your work. Okay? So the answer's in some ways the least important part, in other ways the most. Anyway, so our conclusion is therefore g of negative 8, or we could, let's say it differently. Let's say g of x is not continuous at x equals negative 8. What's up? Miss Ocean.
Why not?
The 3 dots mean therefore, guys. You should have done the 3 dots. Listen. The 3 dots mean therefore. It's a scientific thing. This in Spanish doesn't make sense, which is probably why it doesn't make sense to you guys. In English, we call it at. You guys call it arroba. That's why it doesn't make sense. We say at. So it's continuous at x equals negative 8. That's what it means in English, man.
Can I just put at?
Yeah, you can. I just think that takes longer. Put at then. I don't care. It means the same thing. All right. Next one. You ready? How about we try this? How about we try it this way? Okay. If you are in the back 2 tables, so the ones in the back of the room, you're gonna try this one. Front 2 tables. I want you guys to try this one. I'm gonna do them without talking. Okay. And then we'll check them. Okay? Approaches negative 6. X equals negative 7. G of negative 6 equals the limit. As x approaches negative 6 of g of x. And this equals negative 7. Therefore, g of x is continuous at x equals negative 6. G of negative 4 equals negative 5. The limit as x approaches negative 4 g of x does not exist. Look here. Therefore, there are 2 different things from left to right. Therefore, x equals negative 4. Once you guys are done, you can check your answers up top. Okay? You're not supposed to look immediately. Check your answer, man. It means finish it and then look. Are you lying? Lying's a sin. Okay, good. All right. Back 2 tables. You guys did the first one, right? Anybody have any questions about that one, or did it make sense? Okay. So front 2 tables, listen up. I'm going to quickly go over it while you write it down. Basically, the function at negative 6 existed. It was negative 7. The limit at negative 6, if we look over here, is negative 7. It's right there, right? Both sides are the same. Since those 2 things are equal, and I like to write it this way, g of negative 6 equals x, the limit as x approaches negative 6 of g of x equals negative 7. Showing what it equals, that they're all equal, and then you can say it's continuous. Okay? If you're asked for the definition of whether or not something is continuous, guys, you need these 3 things. Okay? All right, front one. Any questions from the front 2 tables? No, it was good? All right, back table real quick so you can see. Okay? G of negative 4 existed. It was negative 5. The limit, however, did not exist. So if we go look here at negative 4, it existed, right? It's negative 5 because that dot is filled in. However, our limit didn't exist. We got negative 2 and negative 5 from left and right. So therefore, since the limit doesn't exist, that means that the whole thing's not going to be continuous. Okay? I understand that, like, to understand the answer is easy. What I'm trying to get you guys to realize is this is how we mathematically prove it, that it's not continuous, okay? Which I know seems like a bunch of extra work, but like I said, part of what we're doing now is you guys have to prove or back up what you claim.
I have a question.
What's your question?
We don't have to put it left side, right side.
Here? I mean, you could. It's not a bad thing to put it, but no, at this time it's okay to just say does not exist. But it's not a bad thing to say left side doesn't equal right side. All right. What about if I take away the graph, guys? So let's take a look at these next ones. I'm going to take away the graph, and we're going to see if you can figure out how to do it still. It's the same process, but there's no graph. Okay? So the very first... Don't whine.
I don't like
Amalia, you'll be all right. All right, so the first thing is it has to exist. Now, obviously it's saying at negative 2. I could have figured out it was negative 2 without them writing that. Why would I be able to figure that out? Yeah, because the boundary points are negative 2. that's where something interesting might happen. Obviously, before that or after that, it exists. What's the only time that all three of these functions are going to have a problem? There's only one time that they're going to have a problem. If x is what?
They gotta be one too.
No. Nope. If x is less than -6, right? This one's fine everywhere. Watch, I can tell you. This one's fine everywhere. Exponential, fine everywhere. Cosine, fine everywhere. The only problem is if this root becomes negative. So if x is less than -6, it's going to be undefined, right? Since we're asking about -2, we need to check all those. So first thing is, does it exist? So does f of -2 exist? Which of those three functions am I using? The middle one, because it's when it equals -2. And sure enough, I put it in there. Of course it exists. It's going to give me -6 plus 2, -4. Okay, so that, perfect. First criteria met. Second criteria is we need to know if the limit as x approaches -2 of f of x exists. Well, to do that, I need to look at both the left side and the right side. Would you agree? Yeah? All right, so let's do that. Let's look at both the left and right side. On the left side, which function do I need to use? The top one, right? When it's smaller. Okay, so I'm going to just plug it in. I'm going to get -2 times the square root of -2 plus 6, right? That's going to be -2 times square root of 4, which is 2. So it's just going to give me -4. And we're trying to figure out, are these equal? Okay. On the right side, right? On the right side, hey ladies, I need to check the bottom function, right? Because this time I'm bigger than -2 on the right side. So I'm going to get e to the -2 plus cosine of -2 pi. I'm pretty sure you don't even need to do anything else to be able to tell this is not true, right? Like there's no way e to the -2 is somehow turning into 4, right? It's not happening. So sure, you could say, oh, the cosine of -2 pi is 0. Great, good for you. The point is, -4 does not equal e to the -2 plus 0, right? Sorry, not plus 0. Oh my gosh, I can't believe I said that. Plus 1, sorry. Cosine, not sine. Cosine of 2 pi. Either way, it's still not true.
Do you know how many circles are
Because I use the unit circle, and I learned it when I was, in school. Unlike you guys. All right. So once that's true, once it fails one, you guys, you don't have to keep going. Listen, this is important, guys. I don't need you to say the third one. Okay? It failed the second one. I can immediately go to the conclusion. Therefore, f of x is not continuous at x equals -2. Okay? If it fails the first criteria, you're done. If it fails the second, you're done then. If it fails the third, you're done then. If it doesn't fail any, it's continuous. Come on, man. We just did it. We just wrote it down. Look on your page.
No, that's so much information at the same time.
Those two things have to be equal if they exist.
Okay.
We're going to do an example like that anyway. Okay? All right. You guys got that one down? Can we do number 5? Yeah? Who said wait? All right, Matthias. We'll wait for you. Now he's good. All right. So this time it looks a little different. It's still a piecewise function, but there's only 2 functions. So we got to think about it a little bit more. So g of pi, does that exist? First of all, which function am I using? Top or bottom? The bottom one, because it has the equal sign, right? All right, so it's just going to be e to the power of pi times tangent of 3 pi over 4. We might as well simplify that. So obviously the e to the pi is not going anywhere. What about tangent of 3 pi over 4? So anytime it's pi over 4, it's 1 or -1. Which one is this? -1, why? Which quadrant are we in? Second quadrant, tangent's negative in second quadrant. So this is negative e to the pi. Okay? See? You guys are good. You got some knowledge on the unit circle. All right, so it passed the first one. Next one, the limit's got to exist, right?
Wait.
What am I waiting for?
So your answer is -5.
Negative, what? No, my answer is negative e to the pi. But I'm not done yet. Okay, I got to keep going, right? Okay, now here's the beauty of this one. I still need to check the left side and the right side. But thankfully for me, I already did the right side. The right side is this, because we only had one equation for that, right? So all I really got to do is check the left side. So that's easy. E to the pi times cosine of pi. What's cosine of pi? -1, so it's negative e to the pi. Therefore, these two things are equal. So it passes the second criteria. Third criteria is, are those two things equal? Well, yes, because this time, like, it's the same equation. Yes, Pedro.
So g of x is continuous at x equals pi.
Yes, but we're not done. We got to write the third criteria down still. But yes, so we do still need to write it, okay? So g of pi equals the limit as x approaches pi of g of x. And what does that equal? Negative e to the pi. So it passes our third criteria. Pablo, you were asking that? That's that third criteria, okay? And so now we can say, therefore, g of x is continuous at x equals pi. Does that make sense, everybody? We're feeling good? Except for the two that came in late. They're feeling scared. In the dots. Did they mark you here, or do I need to switch it? Okay, I'll do it.
Yeah,
That's all good. What's that? Sorry? Really? If you don't put the dots and you just put g of x is continuous, it's okay. You should put therefore, though. Like, you should write therefore. It's a conclusion. Then write therefore. It just means therefore. The three dots. Yeah, because you guys should have done that in science class, right? All right, we're gonna do another one. Are you ready? Are you guys ready for this one? This is where it gets fun. It gets interesting. This is where it's going to get interesting because we're going to see how well you guys remember your pre-calc and your algebra. You guys remember systems of equations? That's what we're going to do. Some friend. All right, let's take a look at it. You're going to have to look at somebody else if you're not done. Amelia, you good or you have a question? All right. So let's take a look at this one. Here we got our function over here. It's got three different equations. What do you notice that's different about this one from the previous ones? It's got variables. That's one difference. What else? Good. It's got two different boundary points, right? It's something interesting could happen at -1. Something interesting could happen at 3, right? If we look at these functions, they're clearly defined everywhere. So the only potential problems are at those boundary points. Do they meet up? Or do they not meet up? Right? And that's what we need to check. Okay. I guess I should have made the line straight since it's 2 and -2, but whatever. All right. What two limits must equal in order for f of x to be continuous at x equals -1? Only at -1. This means that the two limits are the limit as x approaches -1 of f of x, but from the left has to equal the limit as x approaches -1 from the right of f of x. Now, for our sake, let's write down what that actually means. The left side of -1 is 2. That's the function, right? And the right side is mx plus k. We don't know anything more than that yet. Actually, that's not true. I can simplify that a little bit. Because what is x? Hang on. What is x? -1, right? Because we're checking that boundary. So we could actually simplify this to -m plus k. Pablo, go ahead.
Can we just determine that if the right side equals 2 and the left side equals -2?
Yeah, but how are you going to do that if it's m and k? I mean, I agree with you, but how are you going to do that? How are you going to prove that this equals 2 if it's m and k? You can't. So that's why we're solving it this way, okay? Amelia, I got the negative. Okay, good. So now my boundary point is 3. So the two limits are the limit as x approaches 3 from the left of f of x. We need it to be equal to the limit as x approaches 3 from the right of f of x. And in this case, let's go ahead and write it right away, I guess. So instead of being mx, well, no, I'll write it out actually. Mx plus k is equal to 3. But I can simplify that because I know what x should be. It's not equal to 3. It's equal to negative 2. I'm getting ahead of myself. I apologize. X is 3. So it's 3m plus k equals negative 2. Apologies for writing the 3 in the wrong spot. That makes sense to everybody? Ish? Not yet. But now I can find m and k, so it's continuous everywhere. Because if I have 2 equals negative m plus k, and I have negative 2 equals 3m plus k, that should look like something you did in pre-calc or algebra or whatever course you took before this. Huh? It's a system of equations, and it's even easier. It's a system of linear equations. So what could I do to these two equations? I can either do substitution or elimination. I would argue in this case elimination is easier because if I subtract these two equations, what happens to k? It's gone. So I'm going to subtract those two equations. So 2 minus negative 2, that's 4. Negative m minus 3m, that's negative 4m. And k minus k, that's 0. So it's gone, right? Then I can divide by negative 4.
Why did you subtract that?
I just said it, man.
Yes, but I didn't hear you.
I don't know, because you were talking.
I wasn't speaking.
No, you were. Your table was talking. Maybe you should move. Okay. Why did I subtract them? Because the k is going to go away. K minus k, right? I can either do substitution or elimination. Because these are already set up as elimination, essentially, I just did elimination. I could have solved for k and plugged it into the other one. I also could have multiplied the first equation by 3 and added them and got rid of m. But I'm always going to do whatever's least work, right? This is the least work, so let's do that, okay? Now that I have m, I can go and plug that into either of the other two equations and solve for k. So I think maybe the first one's easier. 2 equals negative 1 plus k. So 2 equals 1 plus k. I subtract the 1 to the other side. K is equal to 1. Okay? If I plugged into the other equation, would I get the same thing? Yes, right? We learned that previously, so I don't need to go over it again. And so we're done. Those are our two answers. If m is negative 1 and k is 1, this thing will be it'll be continuous everywhere. Now, I'm going to draw a quick picture so you can see what it is. If we're at x is negative 2 and then x is 2, no, sorry, I apologize, negative 1 and 3. At negative 1, it was 2. At 3, it's at negative 2. And basically what I have then is I have the other function that looks like this, and I'm moving it up and down so that it perfectly lines up with these 2 points at 2 and negative 2. Does that make sense? That's what I'm trying to do. I'm moving that linear function up and down to make sure that it's going to perfectly line up and make those continuous. That's what we just did, okay? Because obviously if I have 2 lines, I can create a third line that connects them. I just need to figure out what the heck that line is. So that's what we did. To show you what it means? Not yet. You will eventually.
But not in this module, not in 1.6.
Nah, you're okay.
So we're like
All right, ready? Last page. Here we go. Actually, you know what? Since it's the same thing, let's actually get you guys to try it on your own. I think we should. I think we should.
You know what?
Try it on your own. Okay, I'll write down the answers. I'm going to talk to myself because I'm talking to the camera, so don't eavesdrop. All right. So what are my 2 limits that need to be equal? At x equals negative 2, I need the limit as x approaches negative 2 from the left of g of x to be equal to the limit as x approaches negative 2 from the right of g of x. And if we plug in what those things are, I can look up here, and I'm going to get that it's going to be, I'll write it here first for you. K x squared plus m is equal to 4x plus 1. Then I'm going to plug in what x is, so it's negative 2. So I'm going to get negative 2 squared plus m is equal to 4 times negative 2 plus 1. Over here, I get 4k plus m. Here, I get negative 8 plus 1, negative 7. So that's the first one. Second one, at continuous at 3, means I want the limit as x approaches 3 from the left of g of x, and I need that one to be equal to the limit as x approaches 3 from the right of g of x. Showing what those are, that's 4x plus 1 needs to be equal to kx minus m. Then, of course, I can plug in 3 for my x, so I'm going to get 4 times 3 plus 1 needs to be equal to 3k minus m. This simplifies to 12, 13 equals 3k minus m. There's my second one. So now I can make this continuous everywhere by forcing these things to be equal. So that means that I've got to solve the system of equations. So 4k plus m equals negative 7, and then I've got 3k minus m equals 13. Easiest way to do this is elimination, so I'm going to subtract. 4 minus 3 gives me 1k. Sorry, I'm going to add, not subtract. 4 plus 3 gives me 7k. The m's go away. Negative 7 plus 13 gives me 6. And so k is going to be equal to 6/7. Then I'm going to plug that in. 4 times 6/7 plus m equals negative 7. That's going to be 24 over 7 plus m equals negative 7. Then I'm going to move that over. So I've got that m is equal to negative 7.
He's writing on the desk.
Minus 24 over 7. Then I'm going to need to have a common denominator so that I can put that together. So that's going to be negative 49 over 7 minus 24 over 7. And my final answer is going to be 73. Negative 73 over 7. So those would be the two values that I need in order to make these this function f, or g of x, continuous absolutely everywhere. All right, so when we did this, the first two limits, which I think most of you got, right, is at negative 2, I need to use these two functions. Why? Because those are the two where negative 2 is a boundary. Okay, so I did those two limits. I actually wrote the limits, okay? Then I wrote down my two functions that had to be equal. Then I substituted in negative 2 for the x value, okay? Be careful when you're doing this one. A lot of students, if you put that in your calculator, it's going to tell you negative 4. It's not negative 4, right? It's negative 2 all squared, which means the negative cancels. So you get that function once you simplify it. Second one was for g of x, and this time I needed these two functions. Why? Because that's where it was equal to, or that's where 3 is a boundary point. Okay? So I wrote down those two limits from left and right of 3. I wrote down those two functions. Then I substituted in 3 for the x's. That gave me 13 equals 3k minus m. Now, this is where I know a lot of you got stuck. You wrote down these equations and you were like, what do I do? Well, you have to kind of just analyze it. If I subtracted these, I'm going to get I'm going to get k and positive 2m. That's not helpful. It didn't eliminate anything. If I add them, I'm going to get 7k and 0m. That's helpful. Let's say neither of those were helpful. Maybe I need to multiply this one by one number and this function by another number so that they are going to be the same coefficient and they'll cancel. Or I just do substitution at that point, probably, right? Like I tend to do elimination if it's easy and substitution if I got to do a bunch of work, okay? That's where I solve one of the equations for m or k and plug it into the second equation. Now, once I did that, I recognized I could add them. I got 7k equals 6. K is just 6/7. A lot of you got that when I was going around. Then you got stuck again. Remember, guys, once you have it, all you do is you plug it back into the equation. Which one? Doesn't matter. Either one of them. So here I plugged it in for the first equation. So 4 times 6 over 7, that's 24/7. Then I need to solve for m, so I didn't write this step, but what I did is I subtracted 24/7 from both sides. That meant I got negative 7 minus 24/7. If I don't have a calculator, which you usually won't in calculus, right, then I'm going to have to convert that to have a common denominator. So negative 7 is the same as negative 49 over 7. That means that now I can add these, so I get negative 73 over 7. Make sense? Any questions about it? No? All right, guys, you can finish writing that one down.